Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to continue looking at the metric system for the sciences, and in particular we're going to look at combined units. In the previous video, I talked about how we change from one metric unit to another metric unit. So for example, if we had a measurement of 60 milliliters, we were able to change that to deciliters. Or if we had a mass of 0.2 grams, we could express that in micrograms. If you haven't taken a look at that video yet, I strongly recommend you do that first before this video. Now what we're going to take a look at is if we have combined units. So for example, if I have a concentration of 150 grams per milliliter, and I want to express it as micrograms per deciliter, we need a strategy to do that. Very similar to what we did in the last video, but a little more involved because now we're changing not just grams to micrograms, but we're also changing from per milliliter to per deciliter. So let's take a look at how we can do that. Have all of your metric prefixes handy. You know, I'm sure that you can print them off from the internet, and refer to these when we're doing these questions. I'm going to start off with a concentration of 15 milligrams per deciliter, and I'm going to change that to grams per liter. So in order to change 15 milligrams per deciliter to grams per liter, I deal with one unit at a time. So I start with the numerator, and I want to change from milligrams. So because it's in the numerator, to change it needs to go in the denominator so that it can cancel, and I want to replace it with grams. Then I go to my chart. I'm dealing with milli. Milli has a value of 10 to the negative 3. So I know 1 milligram is equal to 10 to the negative 3 grams. That allows me to cancel the milligrams. Now my concentration will be in grams per deciliter, but I want grams per liter. So now I'm going to change per deciliter to per liter. In order to do that, because deciliter is in the denominator, I'm going to put it in the numerator to cancel it. So I'm going to put deciliter in the numerator and replace it with liter. And I look up my value for deci on my chart. Deci is 10 to the negative 1. So I know that 1 deciliter is 10 to the negative 1 liters. Deciliter will cancel. As I mentioned in the last video, your 1 should always be with the unit that has the prefix, and your power of 10 should always be with the unit that's your base unit, so without any prefixes. The 1 is with the unit that has the prefix, and your power of 10 should be with the base unit. Now that my units are taken care of, now I do the calculation. So it's going to be 15 times 10 to the negative 3 over 10 to the negative 1. It will be grams per liter. Simplify using my rules of exponents. If I'm dividing two powers with the same base, I subtract the exponents. So it will be 10 to the negative 3 minus the negative 1 will be negative 3 plus 1, which will be negative 2 grams per liter. I don't want to leave it in that form. That's not proper scientific notation, so I need my number to be 1. I need this to be between 1 and 10, so I'm going to move my decimal point over one place. Because I divided by 10, I've got to multiply this number by 10, so I add a 1 to the exponent. And the concentration will be 1.5 times 10 to the negative 1 grams per liter in scientific notation, or 0.15 grams per liter as a normal number. Again, your choice of how you want to express it. Let's take a look at some more examples. In my next example, we have 0.2 milligrams per liter, and we want to convert that to micrograms per milliliter. So my first step is to deal with the numerator, and I want to change from milligrams to micrograms. I need to go to the base unit of grams first. So from milligrams to grams, and then once I'm in grams, then I can go to micrograms. So milli is 10 to the negative 3, so 1 milligram is 10 to the negative 3 grams. That takes care of milligrams. Now let's go to micrograms. So my next fraction will change from grams to micrograms. Micro is 10 to the negative 6. So 1 microgram is 10 to the negative 6 grams. The grams will now cancel. So I've got my mass in micrograms. I want to change the capacity from per liter to per milliliter. So my next fraction, liters in the denominator, so in order to cancel it, I need to put it in the numerator, and I want to go to milliliters. Milli is 10 to the negative 3, so 1 milliliter is 10 to the negative 3 liters. Liters will cancel. Now I do the multiplication. So I'll have 0.2 times 10 to the negative 3 times 10 to the negative 3. When I'm adding powers with the same base, I add the exponents. So that will be 10 to the negative 6. In the denominator, I have 1 times 10 to the negative 6 times 1 will be 10 to the negative 6. My unit will be microgram per milliliter. 10 to the negative 6 times 10 to the negative 6 is a 1. So it'll be 0.2 micrograms per milliliter. Let's try a couple more examples. We have 400 nanograms per deciliter, and we want to change that to a concentration in micrograms per milliliter. So we want to change nanograms to micrograms. I need to go to my base unit of grams first. So I'm going to put nanograms in the denominator and grams in the numerator. Nano is 10 to the negative 9. So 1 nanogram will equal 10 to the negative 9 grams. So that will cancel. Now I want to change from grams to micrograms. Put grams in the denominator, micrograms in the numerator. Micro is 10 to the negative 6. So 1 microgram is 10 to the negative 6 grams. So now I've got the mass unit that I want. Now let's deal with our capacity unit. So I'm going to go from deciliter to liter. I'm going to go to my base unit first because deciliter is in the denominator. In order to cancel it, I need to put it in the numerator, and I'm going to replace it with liter. Deci is 10 to the negative 1. So 1 deciliter is 10 to the negative 1 liters. So that cancels the deciliter, but I don't want to leave it in liters. I want milliliters. So now I can go from liters to milliliters. Milli is 10 to the negative 3. So 1 milliliter is 10 to the negative 3 liters. So you can see I'm going to be left with microgram per milliliter. Let's do the calculation. So I'm going to have 400 times 10 to the negative 9 times 10 to the negative 3. I add the exponents, 10 to the negative 12. Divided by 10 to the negative 6 times 10 to the negative 1 will be 10 to the, I add the exponents, negative 7. And that will be micrograms per milliliter. In order to divide, I subtract the exponents, so that's going to be 400 times 10 to the negative 12 minus a negative 7 is negative 12 plus 7, so negative 5. I'm going to change this to scientific notation. So I'm going to move my decimal point 2 places to get a number between 1 and 10. And then I have to add a 2 to this exponent. So 400 nanograms per deciliter will be equivalent to 4 times 10 to the negative 3 micrograms per milliliter. It doesn't matter how ugly these prefixes get, the procedures are the same. I want to change 50 femtograms per microliter to microgram per centiliter. So let's start with our mass. Before I go to microgram, I'm going to go to the base unit of gram. Femto is 10 to the negative 15, so 1 femtogram is equivalent to 10 to the negative 15 grams. Then I want to go from grams to micrograms. So grams in the numerator, I put it in the denominator, replace it with micrograms. Micro is 10 to the negative 6, so 1 microgram is 10 to the negative 6 grams. So I've changed femtogram to microgram. Now let's change from per microliter to per centiliter. In order to do that, I'm going to go from microliter to liter. It's in the denominator, so I need to put it in the numerator. Replace with liter, so I always go to the base unit first. Micro, 1 microliter is 10 to the negative 6 liters. And then I want to change from per liter to per centiliter. So liter goes in the numerator so that it cancels, and replace with centiliter. Centi is 10 to the negative 2, so 1 centiliter is 10 to the negative 2 liters. So I'm going to end up with my correct unit, micrograms per centiliter. Let's do the calculation. So it'll be 50 times 10 to the negative 15 times 10 to the negative 2. I add the exponents, so negative 17. In the denominator, I have 10 to the negative 6 times 10 to the negative 6, which would be 10 to the negative 12. My unit would be micrograms per centiliter. I simplify that by subtracting the exponents. So that would be 50 times 10 to the negative 17 minus a negative 12 would be negative 5. I can't leave it in this form. If I'm dealing with powers of 10, it has to be in scientific notation. This number has to be between 1 and 10, so I'm going to divide by 10 here, which means I multiply this part by 10. So this becomes 5 times, when I multiply this by 10, I add a 1 to the exponent, so 10 to the negative 4. So 50 femtograms per microliter is equivalent to 5 times 10 to the negative 4 micrograms per centiliter. So just go step by step, deal with the numerator first, go to the base unit if necessary, and then work with the denominator. Again, go to the base unit if necessary, and then the final unit. If you happen to have a question that involves time, the process is the same when you're changing units. We can use dimensional analysis. So we'll worry first about changing meters to kilometers, and then per second to per hour. So we're going to have 120 meters per second. We want to change from meters. So meters is in the numerator. To get rid of it, it goes in the denominator. And we're going to replace it with kilometers. So kilo is 10 to the power of 3. So 1 kilometer is 10 to the 3 meters. Then we want to go from per second to per hour. So we could go from seconds to minutes and then minutes to hours, or you can go straight from seconds to hours. I'll go through 2 steps. I want to eliminate seconds. I'll put it in the numerator and replace it with minutes. We know that 1 minute is equivalent to 60 seconds. So as long as these 2 are equivalent, that's allowed. That gets rid of seconds. But we don't want to leave it per minute, we want it per hour. So now we get rid of minutes, we put it in the numerator, and we put hours in the denominator. Again, the numerator and denominator have to be equivalent. We know that 1 hour is equivalent to 60 minutes. So now we can do this whole calculation. When we take 120, multiply by 60, multiply by 60, divide by 1,000, we get 432. The unit will be kilometers per hour. So a speed of 120 meters per second will be equivalent to 432 kilometers per hour. So it doesn't matter if it's metric units in both the numerator and the denominator, or if time is involved in the denominator. Just remember the process of dimensional analysis, remember your equivalents, and it should work out just fine. Try to practice changing from one combined metric unit to another combined metric unit. And again, the more you practice, the better you get.